Hi Spring fans! Welcome to another installment of Spring Tips. In this look, we're going to take a look at Jersey, the sort of JSR 311 and JSR 339 reference implementation for the JAX-RS specification, and particularly how it integrates with Spring Boot 2.0, right? And of course, Spring Boot 2.0 is still early days yet, so we're going to look at a snapshot. This is actually this is going to have all these features will bubble into Spring Boot 2.0 M4, which hasn't yet been released, and we're just going to look at how it works, what are some of the nice features of it, how to get going with it, and so on. So we're going to build a new application. We're going to call this the customer service. All right, that's just our application. We're going to use Spring support for building. We're going to use the we're going to use the Lombok compile time annotation processor. We use Jersey itself. Now it's worth mentioning that we have other. There's another implementation of JAX-RS that's supported here, right? So CXF. Let's see in Spring Boot proper, Spring Boot 1.47 or 1.57. You'll see CXF. But it's worth noting that we keep support. We integrate wherever we can JAX-RS implementations, and so for earlier versions, there's at least two versions right now. In the early days of Spring Boot 2.0, there's Jersey, so we're going to use Jersey, and we are going to use JPA. We're going to use H2, and then we're going to use the actuator. Right, the actuator are a set of endpoints that surface information about the application to serve the goals of observability, so that you can understand what your system is doing. And I think that will be enough. So let's go ahead and hit generate. That'll give us a new project. And we'll open this up in our IDE. And again, I've got a convenient little script here now. These days, I keep a little script, UAO, customer service. And that'll open up the application for us. Okay. All right, so we have now our customer service application. We're going to build a resource, of course. So we're going to go here. We'll create a JAX-RS REST endpoint. So we'll say insert a new class, customer resource, and it's fair to assume that this customer resource is going to manage entities of type customer. So we'll create that as well, a new customer, and our customer will be a JPA entity, and we'll give it a private long ID and a private string name, and the ID we'll say ID at generated value, and we need some getters and some setters and so on, so we'll use Lombok to generate all that and make short work of that work. Okay, so now we have the entity. We need a repository, right? So let's create a customer repository so that we have no need to fiddle with low-level data management, right? That's just a function of Spring data and the repositories. So we've got now we have an interface. Let's see, there we are. It's an interface. Now we can go back to our resource, and we're going to build a application that what is it? It's going to produce application JSON, right? It's a REST endpoint using JAX-RS. So we're going to use application JSON. We're going to map the whole thing. The whole class will be rooted at /customer. So all requests will be relative to that URI there, that path. We're going to have one endpoint here that'll return a single customer. So let's try that. A single customer by ID, right? So there we are, long ID. I'm going to give this a GET mapping. So it's going to map to an HTTP GET request. And we'll give it a path of parameter ID. Okay, now that's going to need a path param in the URL there. Okay. Of course, to do this, we're going to need our repository, our customer repository. So let's inject that into the constructor, and we'll return customer repository.find by ID. Now, of course, this is going to throw an exception. It's an optional that we get back, so it could throw an exception. So we're going to say it could return null rather, and so we need to do something with that. So we need to throw an exception. We could say couldn't find ID. Right, there we are. There's our simple example, as simple as it gets. So now that's one endpoint. I can also imagine wanting to have another endpoint here for all of the records. So public collection of customers, and we'll just return this.customer repository to find all. All right. Now we have our simple JAX-RS endpoint, but this is not in of itself enough, right? We need to actually configure one little tiny bit just to make this work in the Spring world. So we're going to go back to our configuration here, our application, and we'll just we'll create a new configuration class called Jersey configuration, And therein, we're just going to put anything that we need related to making Jersey work, right, in a Spring Boot context. So the first thing that you absolutely need before you can do anything else is a config object, a resource config. And the resource config is, kind of the centerpiece of the API, actually. So you return one of these, and this actually activates the Spring Boot auto configuration, but it's also where we need to register components. So we need to teach Jersey about the beans that we'll be managing. We can do this a couple of ways. We could tell it just to scan the scan a certain package, right, or set of packages. We could look for certain classes, packages, etc. We could do a lot of different things here, but we're just going to register beans dynamically. We're going to create beans using Spring and then pass them the references to those beans as we go. So the first thing that we need to do is to tell it where to find our customer resource. So bean customer resource. And this will, of course, depend on the customer repository. And we'll say new customer resource, passing in the repository. Now let's inject that into the endpoint here, CR. And you'll say register CR. Very good. So there's our first simple endpoint. Let's just start the application up and see what we get. Now I'm going to use the shell here. Curl. Let's do HTTP localhost 8080/customers. All right. So there's our first endpoint. There's no data naturally. I've got to insert some data. So let's just create a for now, so they have something with which to play. We'll create some sample data. So data, and we'll just have an application runner. This is a callback interface in Spring Boot naturally, and it's an ideal place to put any kind of sample data or any kind of back office initialization, anything that happens outside the traditional request response lifecycle of an application. So we're going to say stream.of a b c dot for each x cr dot save new customer, passing in null for the ID, passing in x for the name. And this, of course, is a nice fit for lambdas, so we'll just use that. It's a little bit nicer, and we can clean that up a little bit. All right, there we are. So we have our sample data, and if we were to run the application again, which is what we're going to do, we can now hit the endpoint, the shell, and try again. There we are. There's our few records. So everything's working out of the box. We already have a working JAX-RS application. We can see the results here as expected. Everything's fine. Now let's talk about what happens if we go to that second endpoint, the endpoint by ID. So endpoint 1. All right. Okay. We got a single record by its ID. Now what happens if I go to endpoint 6? Well, of course I've only got 3 records, so it's going to fail, right? It's going to throw a big fat Java exception there. So we need to respond to that. We need to care about the fact that that just happened, and sending back a big fat Java stack trace to the client, while convenient, isn't exactly a good form. So we should take advantage of some sort of generic mechanism so that we can return a response, a thoughtful response back to the client. And remember, most of our clients are not going to be human beings as we are right now, hitting the API through a shell, but instead other API clients. So we really want to have something predictable. And this is a good mechanism, good use for the exception mapper mechanism in JAX-RS. So we're going to say generic exception mapper implements exception mapper, and we're going to map a legal argument exception, right? So when we have an exception thrown anywhere in our resources, we're going to tend to it by returning just a response, a specific type of response. Response server error. We're going to have the entity, which is the body, in this case the exception string, and then we'll just build it and respond with that. And we can just tell Spring about this and inject that generic exception mapper into our bean configuration here. Okay, so let's do that again. em resource config register exception mapper. There we are. Okay, so now let's try this again. And go to the shell. All right, let's try. Look at that. Couldn't find number 6. So we made a request, but instead of getting the big fat exception, we had control over the output. And of course, we were able to return HTTP 500. We could do something more interesting. We could say instead that we're going to return VND errors, which is a pretty popular, albeit non-standard representation of errors. There's a number of these things out there. You can choose whatever format or encoding works for you. But for our purposes, we have something, so we know how we would do it, right? We'd create an exception mapper. All right, so that's a pretty useful thing to do. What else do we want to do? We've got a web application. We built a REST API. You can see the REST API wasn't all that hard. Indeed, none of this is all that hard. A common concern when you move to microservices, as you may with JAX-RS or Spring MVC or anything else, is observability. I care about how this application is behaving, and it doesn't matter which organization you talk to. One thing is surprisingly consistent. It's the approach that they take as soon as the pager, or rather pager duty, goes off. Right? Something has to happen. Somebody gets woken up and roused to a computer and has to respond. And all the information that we can do, all the information that we can surface to support that effort, that remediation process, is valuable. So Spring Boot has long had the actuator, and the actuator is a very, very convenient set of endpoints that are exposed. Well, first of all, they're view agnostic, so they've been exposed over REST and they can be exposed over JMX and so on, but they're not bound to any one particular representation. You can get the same information. You used to be able to get the same information through the Crash Hub shell, for example. I mean, there's just a number of different ways to get this information. Well, one thing that people have often clamored for was the ability to use the actuator endpoints with a JAX-RS application, right? The actuator endpoints used to be tied, at least insofar as they were tied to an HTTP interface, to Spring MVC. Well, that's no longer true. In Spring Boot 2.0, where we're reimagining the actuator infrastructure to be sort of web runtime agnostic, because we have to do that to support the sort of dichotomy between Spring Web Flux, our reactive web runtime, and Spring MVC proper, which is a servlet, or at least servlet anchored web runtime. Because we have to do that anyway, we've also got the freedom to support things like JAX-RS. So we have the actuator on the class path. All we need to do is to activate them. So activator, endpoints rather, dot web endpoints, right, default web endpoints dot oh, did I get the wrong build? I did. Build hyphen snapshot. Okay. Now we're okay. Let's see what we got here. Endpoints dot default dot web enabled equals true, and we'll run the application again. There we go. And we'll go to the shell and make a request. Number 1. That's all working. Good. Now we go to application. Health. Now application is just a default context path, but you can, of course, you can configure that as you see fit. So let's see what we got here. Come on, come on, shell. There we are. Good. So there's my health endpoint. All the configuration for that particular application. There's the env endpoint that shows me the system properties and environment variables, all that kind of stuff that I may want to debug configuration from one node to another. That's Delta's in particular. That's very useful. What else do we have? We have a whole number of different endpoints, which we can enumerate by just hitting the root application path. So all these different endpoints that serve now to help us debug what the application is doing. We've got the usual suspects, the things that you may know from any Spring Boot application here, and so on. And so the JSON, the syntax is a little different, but that's part of the reworking for Spring Boot 2.0 as opposed to just JAX-RS. So now we've got that. We've got a REST API. Are we done? Can we go to production? Well, again, what we care about in Spring Boot is production worthiness, right? So this isn't much of a service unless we have some sort of security. And obviously with Spring Security, you can do darn near anything. So let's bring in Spring Security. I didn't choose Spring Security back at the Spring Initializer because I forgot, but it's not hard to bring it in. So bring in Spring Boot Starter Security. And we're not going to spend too long here. we're just going to set up some security configuration, right? There we are. There we are. There's our configuration. And the first thing that we need to do is to activate web security, right? We need to activate Spring Security. Remember that Jersey is just a servlet and a filter at the end of the day. So Spring Security is agnostic of any particular framework at some level, right? There is a point where you can take advantage of Spring Security, and for example, if you're using the MVC matchers, that's a Spring MVC-ism. But Spring Security works with the Spring WebFlux coming in Spring Framework 5. It works with JAX-RS. It works with any web application at all. That's why for the longest time, Spring Security was the #2 most popular Spring technology right after Spring Framework itself, because even though you need Spring to work with Spring Security, that is, the libraries themselves are sometimes dragged in for Spring Security, you don't have to use Spring Security with a Spring-based web application. So for the last better part of a decade plus, where people have had web applications and they want to secure it, you just brought in Spring Security. That works very nicely, right? So we are going to integrate Spring Security, and the first thing that we want to do is just set up some sort of authentication. So let's create a user details service bean, custom user details service, all right? And user details service bean is just an object that Spring Security will delegate to when it wants to answer the question about who is making the request, right? I want to validate that the request is coming from Josh or Rob or whoever, right? So we're just going to use a new in-memory user details manager, which is in turn going to accept a collection of user details. So let's say arrays.asList, and we're going to create a little convenient method here, private static user details, user string user, and we're going to say that there's going to be some roles. And we'll say user dot with username user. We're going to use the same default password, just a demo after all. But obviously, in a real thing, you'd talk to a database, or you wouldn't even use the user detail service. You'd use some sort of authentication manager that talks to whatever backend identity provider you've got. But in our case, I just want to establish that you can use JAX-RS with Spring Security quite easily. So we're going to create just a simple user detail service that knows about 2 users. User 1 is going to be Mr. Winch, Rob Winch, the lead of Spring Security, naturally. So he'll be an admin as well as a user. And I will be there as just a user, right? So just a user. 1 role for me, 2 for him. Okay, and pass that in there. There we are. There's our collection of users and our custom user detail service. Now, this is interesting in of itself, but I want to also secure the application. I've got security on the class path, but I need to lock down access to the different endpoints, and I want to make sure that you have to be at least authenticated to talk to any of these different endpoints. So let's extend here the web security configure adapter and override the HTTP security. So there's this. I'm going to say HTTP basic will support HTTP basic security, and authorize requests, any request dot, and then that's it. Actually, that's enough to get something useful. So let's now try this again. Okay, and we'll go back to the shell. Here we are. All right, so let's see, HTTP minus verbose. Okay. Oops, there's some configuration issue. Oh, any request authenticated. Okay, so we'll start that again. Go to the shell. Auth application. Okay, good. It says full authentication is required to access this resource. Fair enough. Let's try it now with a auth JLong. Whoa. JLong password. All right, so there's the data. Now let's try it with Rob. There's the data again. Good stuff. All right, that seems to be working. But let's say that instead I want to I want to require that every endpoint be authenticated, but I want to require specifically that the customer's endpoints be admin only, right? So I'm going to use an ant matcher, and I'll say customers / dot has role admin, okay? And we'll leave it like that. Otherwise, we're just creating a very specific matcher for that one endpoint, one set of endpoints, and then otherwise everything else, including the actual endpoints, has to be authenticated. So let's restart the application, and we'll go back to the shell here. Now, he's got access to that, no problem. Go back to me, regular user, no problem. What about customers? So I should not have access to this endpoint, right? Access is denied, strictly. I can go back to Rob here. Okay, there's Rob, and I'm going to go back to the customer's endpoint for him. And you'll see that he has actually access to the data. So in this example, we've got Spring Security locking out requests that are unauthenticated. We've got authorization in place. We've configured authorization. One last bridge, however, is I want my application, I want my resource, my JAX-RS application, aware of the authentication, right? I want to be able to dereference or interrogate the authenticated principal. And this requires a little bit of bridge work. So we're going to write a little bit of code here to bridge the security context mechanism from Spring Security with that of JAX-RS, which turned out not to be all that difficult to do. So we need to create a filter that looks like this. It's a filter, let's see, class bridging security filter, and it's going to implement a container request filter. And the job here, it's a JAX-RS mechanism. Our job here is to plug in a security context object, right? So that security context object is what's going to be on the request when the JAX-RS resource processes the incoming request. So we need to put that on there, and it's not such a big deal, right? We can actually create a very simple one that bridges to our Spring Security context. So there's actually a Spring Security context that keeps a pointer that we can get access to from a thread local. There's a static lookup method that we can use. If you're using Spring MVC, you can just inject that authenticated principal into Spring MVC controller handlers. And there's a similar mechanism in JAX-RS. So once we get this working, we can go, we should be able to rewrite this code and take advantage of that authenticated principal by saying at context, security context, right? So all I'm going to do now is I'm going to log out information about the requesting user. Private file log equals log factory, get log, get class. There we are. Okay, so now we'll put that there, and we'll say this.log.info, and we're going to say context.get user principal, get name was here. All right, so there's our authenticated context. We should be able to print that out when the request comes in because it'll be secured, right? You won't be able to get to this endpoint without going through Spring Security, which will in turn populate this security context. So now let's go back to our filter here. We need to write a custom security context implementation. So private static class bridging security context implement security context. All right, there's our security context contract, and the contract is fairly straightforward. So we're going to inject the Spring Security context here. We're going to call it Spring so that I have an easy time of figuring out which one is which. And we need information about the URL that's being used to make the request. So I'm going to inject the URI info from my my request in the filter, right? So we can actually use the JAX-RS runtime Jersey in this case to inject that there. So let's see, our filter will need that. We're going to say at context URI info. All right, there's this. And now we'll say new bridging security filter, and the security filter, or rather, no, bridging security context. And the context is going to need the Spring Security context, so we'll say security context holder.get context, no problem, this.uri info. All right, so there's our bridging security context. Now let's implement this security context itself. So spring.authentication, done. Spring.security get authentication. We could implement this a number of different ways, but I think the simplest might just be to look at the authorities and see if any of those match. So let's try that. Okay, so we'll say .ini mapping or stream.ini mapping, ini match rather, GA. It's a granted authority object that has a pointer to a authority, and we're going to see if it contains the role S. Okay, so there's that. And finally, we'll say URI info.get absolute path.starts with HTTPS, right? If it's an HTTPS request, we're going to say it's secure. So that seems fine. Spring security authentication. All right, that's our custom scheme there. And otherwise, that seems to be okay. So we've rewritten our REST endpoint, our customer service resource, accordingly to inject that context. Let's now go back to the shell and see what happens. So customers /1. Okay, we got the data back, and if we go to the run output there we are. It says Rob Winch was here. So with that, we've just looked at how to create a JAX-RS application using Jersey and Spring Boot 2.0. We took advantage of the new actuator machinery integration in Spring Boot 2.0. We looked at how to take advantage of Spring security in the application, and everything else should be fairly straightforward. This is just a Spring Boot application. It's using JPA and Hibernate and all that other stuff. We've got Spring Data in the mix. It's a so-called fat jar, so you can just do Java -jar to run the application, to deploy it. So in every other way, it's just what you expect, but it just works very nicely with JAX-RS. So with that, my friends, thank you so much for watching, and we'll see you next time.